Hello everyone, I'm Xiao Gang. Okay, in this lesson, we will mainly complete the HMAC-SHA256 encryption method tested. You can see we open this iFLYTEK thing. Let's just open any protocol. It's not here. Maybe it's hidden. Let's just open any one. Okay, the interface we are connecting to should be this one. It should be the silent liveness detection interface. It's fine, we'll know which interface it is when we connect later. And you'll see there is a very complex encryption here. We won't look at these details. I will walk you through the encryption process. You may need to use the HMAC-SHA256 algorithm to combine. As for this algorithm, sometimes it is not available in the engine's underlying version. So we need to write this encryption algorithm ourselves, and we also need to ensure this encryption algorithm can pass the build. So this moment is mainly about writing this encryption algorithm. Then we are here. We actually introduced one in a previous version. Let me see if my GitHub here can be opened. That is, we can copy the C++ source file into it. We'll open it later. Let's finish this first. Okay, so here we write an XT, simple sync phase. Link, let's call it base because of some basic functionality. Let's give it a .h, then copy it again into this .write. Last class, naming things was a bit troublesome, really troublesome. This pace is a bit slow, it should be fine. Okay, then let's refresh it. Let's write the encryption algorithm for everyone first. Let's write it again. Let's also talk about how we did it before. Previously, we imported other C language files. Found them online. But actually, doing this is sometimes not ideal. Right, because you can't guarantee that what someone else wrote is definitely correct. So now that we are here base, right? Then here we include something like this. Then we switch to this source file. Here, let's put it in. Okay, let's first make sure the compilation passes. Okay, let's prepare a class here. Okay, here we are. We just won't write that. Don't write that anymore. That is our end-to-entry function library, because that depends on the engine. We don't want this module to include the engine. We can have export macros here. So let's copy this export macro over. This export macro is the module name. Plus this, remove the F, then add it to this API. The export macro should be this. Look, because others might also need to use this. The method, right? As for the name, we'll call it this. Okay, good. Then let's take a look. See if it compiles here. Obviously here, it fails to compile because we included the wrong thing. It's formed a circular dependency. Okay, now it compiles successfully. This part is mainly for handling some encryption algorithm related stuff. So let's bring this encryption algorithm over. Okay, so this is our encryption algorithm. Let's make it public. Okay, what it returns is a struct. So I'll also briefly cover this struct. This struct is actually just a simple struct, and it contains an array of fat 8 centiR bits. Okay, as for this array, we can actually delete this comment. This triangle. Here we add a carriage return. Okay, let's correct this comment. This is the algorithm exposed for encryption. It returns the name of this struct. Let's change it. Okay, so this struct returns it. So let's interpret what this parameter is. This first parameter is what you want to encrypt. The starting address of the pointer to this information. We are encrypting binary data. This ensures the accuracy of our encryption. And here is the byte length of the encryption. How long it is, because we must specify the length, otherwise it cannot read this data. Then the next two are the key you use for encryption. So the pointer to the encryption key points to its starting address, and this encryption, the length of this key used. With this, we can proceed with encryption. So how is encryption specifically implemented? It's actually quite simple. So before implementing this encryption, actually, we can use what we mentioned earlier here. What was it called? This thing. We can't click into it. So we should pay attention here. If you want to use other encryption requirements, you can look in this file. It has some things already encapsulated by Unreal, but we don't need that here, right? Then we'll include OpenSSL. Okay, we'll just write it like this here. Okay, it seems there's a duplicate include here. Because some might be used elsewhere, we'll ignore it. We'll just include it like this. Anyway, they're just some header files. You don't need to worry about it. Let's format it. Okay, only after including it, then we declare our struct here. You see, it's this. Let's declare it. This is the data we want to output. Then we put the output. Put it in this position. Put it in this position, okay? Because this thing might be something they want to expand to us. Then we can just import this in. Then return these. So what does this piece of code mean? It actually calls this method. As you can see, this method clearly belongs to OpenSSL, and this is the encryption method you want to use, right? And this is the length of key, and this part is the input, and this is the output, and this is the length of the output. Are you paying attention to compare? As you can see, so that's what it means, right? Okay, so this part is understood. It drops right here. It drops right here. Then you can take a look. You can't navigate to that position either. It's actually this OpenSSL header file. Okay, so this is our encrypted data. After encryption, its characters are a 32-character segment like this. It's a piece of data with 8 values. So our encryption is done. Okay, let's compile it. It should be fine now. Actually, we previously wrote a test plugin for you. All of these are actually for testing. Here, let's go into the 1.0 code. In the 1.0 code, it's actually here. Here, there is a public here, and there is an algorithm in an allegor. You can see it here. There is a file here. This file I found online, and here you can use these algorithms to also complete an encryption method. Its codes are definitely made elsewhere. Just search for it. So obviously this is the init update file. To output such an init update file, to output it in an encrypted way, this method is also acceptable. It actually explained a lot here. Actually, here we set. It should be here. It should not autoplay. You can see in our very early 1.0 version, we had an encryption here. We used this method, but after iterating, I found that following the engine standard writing style, you have to go around and write it this way. This is more appropriate and more convenient because you include this copper key like this. Sometimes it works, sometimes it doesn't. Let's take a look and automatically search for it. Okay, so our algorithm is written, then we'll verify it later. Because it seems inconvenient to output verification right now. Actually, there are many URLs here. For example, encrypted ones. We can see the encrypted ones in the network. Look for encryption. Look again. Hey, look here, there's decryption. Right. So then, actually what we want to say is, as you go through these places, you can accept this HMAC-256 encryption. Okay, so actually there's some online encryption tools here. As for this tool, it's actually not very easy to use sometimes. The reason it's not easy to use is because sometimes we have a more complex process when encrypting, because it sometimes wraps binary data. It also wraps spaces and line breaks. And then with these things, once you wrap spaces and line breaks, the encoding string you input yourself won't match. So just be aware of this. That is, when we are developing, you need these websites when doing testing. Go test it and run through the process. Then when you do it best, just refer to it. When running this process, the best way is to directly refer to its encryption. It will provide some methods in Python or other languages. Have it write these languages and take a look. It's more appropriate. It works for me because I'm more familiar with it. I just ran it with C++ direct. Then actually I saw that I seem to have written a URL for this. Actually, many URLs can be used. See which one is more convenient. Because different URLs, you can't guarantee the website's encryption is correct, because this part is indeed easy to mess up, and it's very normal to get stuck in a pit for days. You can use this URL. This is one I've used before. It's quite convenient. Yes, and generally, some websites, some vendors will provide you with a dedicated online URL for generating keys. This is also quite convenient. So that concludes this lesson. We have written an HMAC-SHA256 for you. This is an interface for encryption in UE5. Thank you, everyone.